Good morning, students. Welcome to the online classes in standard for standard 12th in the subject physics. Today, if you remember, students, I have told that I'll be discussing some of the NCERT exercise questions of chapter 2, electrostatic potential and capacitance. So it begins with exercise 2.1. The question is like this: two charges 5 into 10 to the power minus 8 coulomb minus 3 into 10 to the power minus 8 coulombs are located 16 centimeter apart. At what points on the line joining the two charges is V0? V means electric potential, and it is given take the potential to be 0 at infinity. See the potential formula that we have derived, 1 by 4 pi epsilon naught Q upon R, that we have derived based on this assumption only, that the potential is 0 at infinity. Q1 is positive and Q2 is negative. So its potential will be positive, its potential will be negative. So there is a chance of cancellation at suitable points. Case 1, I choose the point to be somewhere in between Q1 and Q2, this point. And this point will lie closer to the charge having a smaller magnitude. Its magnitude is 5 units, its magnitude is 5 into 10 to the power minus 8 units, and its magnitude is 3 times 10 to the power minus 8 units. The magnitude is smaller, so the point will be closer to that point that I have explained earlier while discussing this chapter. Let its distance from this point be x. Then from Q2, its distance will become how much? 16 minus x in centimeters. X is in centimeter. This is also 16 minus x centimeter. So this is our first point. At this point, potential is to be 0. I will choose this point as P. So potential at point P is how much? That is 0. Now at P, the potential is due to Q1 as well as Q2. Now tell me, students, what should be the value of potential at P due to Q1? It should be 1 upon 4 pi epsilon naught this charge Q1 upon this distance. What is this distance? X. Then potential due to Q2 will be how much? 1 upon 4 pi epsilon naught that charge, that is Q2, upon this distance, that is how much? 16 minus x, and this total has to be how much? 0. So this is our equation that we need to solve for x. Put the values of Q1 and Q2. Now in this equation, 1 by 4 pi epsilon naught, you can see, students, we can take it common, and that will go that side, it becomes 0. So our equation reduces to this. Instead of Q1, how much will we write? So Q1 will be replaced with 5 into 10 to the power minus 8, and Q2 we will replace by minus 3. This becomes minus 3 into 10 to the power minus 8. Now you might feel, sir, why you did not convert this in SI system, that is meters? That is not required, students, because this will go that side, so we'll have equal sign here. Even if you convert in meters, this becomes x by 100, this becomes 16 minus x by 100, so 100 will cancel, it doesn't matter. So our x will be in centimeters. So this equation can be solved easily. 10 to the power minus 8 will cancel from both sides, so we will be left with 5 into 16 minus x is equal to 3x. So 5 into 16 is 80, minus 5x will go that side, that will become 8x. So 8x is equal to 80, means x is equal to 10 centimeter is our answer. But this is not the complete answer. This I have written as case 1. There is one more possibility for potential to be 0, and that will be to the right of this Q2. If you remember earlier, we had discussed such questions. These types of arrangements we have to divide into 3 regions: region 1, region 2, region 3. In region 2, we have found the potential to be 0 at a distance of 10 centimeter from Q1. In this region, if you choose any point, it will always be closer to that charge which has greater magnitude. So always the positive potential due to Q1 at this point will be large. Large why? Because it has larger magnitude of charge and the distance is smaller. This point is closer to this. So never you will have a situation at any point over here where the potential due to Q1 and due to Q2 will cancel. But in this region there is a possibility, because Q2, although it has a smaller magnitude, but if you are very close to Q2, its potential will dominate. So let there be another point, and for that you can draw a separate figure. So case 2, the point, suppose it lies to the right of Q2 and this is the point, and this point I will call it as Q. Let its distance from Q1 be x. Then what will be this distance? This is 16, this is x, so this will become x minus 16. Am I clear to everybody? So earlier we had chosen the point P in between Q1 and Q2. Now we are choosing the same point to the right of that charge which has a smaller magnitude, that is Q2. So its distance from Q1 we have taken it as x. So like we have explained here, similar method you have to follow there. Potential at Q is 0. So 1 by 4 pi epsilon naught Q1 will write as 5 into 10 to the power minus 8 upon its distance, that is how much? X. And then due to this, potential will be minus 1 plus 1 by 4 pi epsilon naught. This charge is how much? Minus 3 into 10 to the power minus 8 divided by that distance. What is this distance? X minus 16, and total becomes how much? 0. Same method will apply, students. 1 by 4 pi epsilon naught will be taken common, will go that side. 10 to the power minus 8 also, same thing. This plus and this minus will become minus. This will go that side, so equal sign will be over here. All these steps are simple. And then we will cross multiply. I am not solving that. You will find on solving that x will come out to be 40 centimeter. So two answers are there, from Q1 at a distance of 10 centimeter and from Q1 only at a distance of 40 centimeter. These distances I have taken from Q1. If you wish, you can write the distances from Q2. The answers will change. For example, from Q2, for first point, the distance should be 6 centimeter, because this is 16, that is 10, remaining will be 6. Likewise from here. So this is the method. Potential is 0, so there are two charges. So what we have done, we have chosen 2 points. You can give the reasoning also in your answer, and total potential was 0. We have applied the formula for potential due to point charge and we have solved the equation. Let's see next question. The second question in our NCERT textbook is this. The question reads like this: a regular hexagon of side 10 centimeter has a charge 5 microcoulomb at each of its vertices. Calculate the potential at the center of hexagon. At each vertex of a regular hexagon means all the sides are of same length. And how much is that length? That is given 10 centimeter. Let this side from the distance from vertex to the center, I will choose it as A, and symmetry says because it is a regular hexagon, all the vertices will be at same distance A from the center. So the potential at the center, which I write as VO, center I am taking as O, is to be found. All the charges are same, so this will become 1 by 4 pi epsilon naught due to a point charge concentrated on this charge. Its potential at the center will be how much? This 1 by 4 pi epsilon naught, this charge Q upon that distance, that is how much? A. Due to charge at B, what will be the formula? 1 by 4 pi epsilon naught, this charge, that is Q, upon this distance, that is again A. Same thing will get here, 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 here. There will be 6 terms. So instead of writing 6 times, you can multiply this expression by 6. Now you know what is the value of Q. So this question reduces to finding the value of A. A is question mark, that you have to first find. Side is given 10 centimeter, this A we have to find. Now see, what is this complete angle, students? One complete angle, you know, it is 360 degree. That complete angle is divided into how many parts? You see, 1, 2, then 3, 4, 5 and 6. So what will be each part? Each part will be how much? 60 degree. Is it clear? So all these angles are 60 degree each. 60, 60, 60 and so on. Now this is A, this is A. So are they isosceles? Is this triangle isosceles? Yes. So these two angles must be equal. If these two angles are equal, you see this is 60. So let this be x, this will be x. 60 plus x will be how much? 180 degree. 60 plus 2x becomes 180. So 2x becomes 180 minus 60, that is 120 degree. So these x will also become 60 degree. So all these three angles are 60 degree. Therefore we can write by geometry OAB is an equilateral triangle. Equilateral triangle. Likewise, OBC, OCD, OED, all these triangles are equilateral. If this is 10 centimeter, each one of them must be 10 centimeter. Therefore, this gives us the value of A as 10 centimeter, that is 10 to the power minus 1 meters. 10 by 100 meters, that is 1 by 10 meters. So put the value of A, put the value of Q. So this becomes 6 into 1 by 4 pi epsilon naught is 9 times 10 power 9. Q is 5 microcoulomb, means 5 into 10 to the power minus 6 coulomb, and A is 10 to the power minus 1, and this much volts will be your answer. Calculation you can do yourself. Let's see the next question. Let's see next question. This is exercise 2.3. Two charges 2 microcoulomb and minus 2 microcoulomb are placed at points A and B, separation 6 centimeter apart. Number A, you have to identify an equipotential surface of the system. Number B, what is the direction of electric field at every point on this surface? Equipotential surface you have to identify. See, this is plus 2, this is minus 2 microcoulomb. It's very much obvious that exactly at the midpoint of them, the potential must be 0. Because 1 by 4 pi epsilon naught Q by 2 by this distance minus 2 by this distance. At the midpoint, the two distances will be same. So therefore, this is our first point where the net potential is 0. But that is not not what is asked in the question. At this point, I argued V is equal to 0, midpoint. So this point I will call as P. So P is the midpoint of AB. Now suppose I draw a line perpendicular to AB passing through P, that means perpendicular bisector. And on that line I choose a point. Will these two distances be same from A and from B? That means I am asking about this distance. Yes, they will be same because this line is the perpendicular bisector of AB. So all the points on the perpendicular bisector at same distance. Therefore, these two distances are same. Therefore, at all these points, potential will again be 0. Let me repeat what I told first. First, I chose a point. That point lies at the midpoint of AB where potential is 0. Then I argued that on the perpendicular bisector of line AB, all the points are at same distance from A and B. Distance will be same. Charges are equal and opposite. Therefore, the potential must be 0 because potential is given by the formula 1 upon 4 pi epsilon naught charge by the distance of the point from the charge. So it is an equipotential line, we can say. Equipotential line. But in question they have asked equipotential surface. Now this perpendicular bisector I have drawn on the board. If you wish, you can draw perpendicular bisector like this, perpendicular to the board. That will pass through the midpoint and that will point towards you, towards the reader. All the points on that perpendicular bisector, their distance from B and from A will also be same. Suppose this distance is x, this distance will also be x. Here the potential will be 1 by 4 pi epsilon naught 2 microcoulomb by x and 1 by 4 pi epsilon naught minus 2 microcoulomb by x. Will they cancel and become 0? Yes, that will become 0. Likewise, I can choose a perpendicular bisector over here, over here, over here at different angles. If you go on rotating this line, you will get a plane, and that plane will look like this, like my palm. That plane will pass through the midpoint of AB and will be like so. This is the plane. That plane will be perpendicular to the plane of this board. So if I try to draw it, let's see if I could. It will be something like this. And this plane is passing through this point. It is difficult to draw in this particular plane because the plane which I am drawing is perpendicular to the line joining A and B. So this is the line, this is the line, and my plane is like this. Are you understanding this? This line is normal to the plane. So that's why I am drawing it tilted like this. So this is our equipotential surface. At all the points on this surface or on this plane, we will find the distance of any point on this plane will be same from A and B, therefore potential will be 0. And since all the points have same potential, that's why it will be an equipotential surface. Now probably you will have 3D view. It's like this. This plane is like this, perpendicular to AB. Okay. So answer to bit A we have discussed. Second part, what is the direction of electric field on this surface? So for B you have to answer that electric field you know is always perpendicular to equipotential surface. Always the electric field vectors are perpendicular to equipotential surfaces. They are normal to equipotential surfaces, in fact I should write. They are normal to equipotential surfaces. Now this equipotential surface is like this, so its normal should be in this direction or in this direction. Out of these two directions you have to choose one. That is obvious. You see, due to 2 microcoulomb, consider the midpoint, the electric field will be in this direction, and due to minus 2, because it is negative, again electric field will be in same direction. So the net direction of electric field will be like so. So what will be answer to second part? The direction of electric field at any point on this equipotential surface will be normal to the equipotential surface along the line joining AB, directed from the positive charge to the negative charge. That means at this point the electric field will be like this, at this point the electric field will be like this, and so on. At any point the electric field will be directed from the positive charge to the negative charge. This is the answer to this particular question. See the next question. This is 2.4 of your textbook. It reads like this: a spherical conductor of radius 12 centimeter has a charge of 1.6 into 10 to the power minus 7 coulomb distributed uniformly on its surface. In no conductor, if it is charged, charge will be present only on the surface of the conductor. You have to find three things regarding the electric field. So what is the electric field at A, inside the sphere, B, just outside the sphere, and C, 18 centimeter from the center of the sphere. So number A, you know, in a conductor, inside the conductor electric field is how much? 0. This we have discussed while discussing electrostatics of conductors. There cannot be any net charge inside a conductor, and using Gauss law we have discussed E is 0. That is the property. B, just outside the sphere, and for points outside the sphere you have to assume the total charge to be present at the center of the sphere. So the electric field, if you forget that this is a sphere and we assume the entire charge to be present at the center, then at this point the electric field will be given as 1 by 4 pi epsilon naught. For a point charge you have to apply the formula. q upon this distance. Just outside this sphere means the distance is almost equal to radius. And for third part, the point is 18 centimeter from the center. Now this was our spherical surface. This is 12 centimeter and plus 6, this much. At this point we have to find the electric field. At this point the electric field will be as if the total charge is present where? At the center. So this will become 1 by 4 pi epsilon naught q by small r square. This distance I take as small r, where small r is how much? 18 centimeter, that is 18 into 10 to the power minus 2 meter. R is how much? 12 centimeter. So R will put as 12 into 10 to the power minus 2 meters. Now in these two expressions you have to substitute the value of epsilon naught and q. So this becomes 9 into 10 to the power 9, q is 1.6 10 to the power minus 7 coulombs, and R is 12 times 10 to the power minus 2 meters. It's a square. Likewise substitute the values here and you can match the answers that you get from your textbook. Let's see next question. See the next question, 2.5. A parallel plate capacitor with air between the plates has a capacitance of 8 picofarad. Pico means 10 to the power minus 12. What will be the capacitance if the distance between the plates is reduced by half and the space between them is filled with a substance dielectric of dielectric constant how much? 6. See, initially we had a capacitor whose capacitance was how much? 8 picofarad, that means 8 into 10 to the power minus 12 farad. Now two things, this suppose separation we take as D and area of the plates of the capacitor we take as A. Then the formula was how much? C equals to A epsilon naught upon D. Now it is given in the question that a distance D is reduced to half, so D becomes D by 2, and space between the plates is filled with a dielectric, so the capacitor would become thin. Now the new separation is how much? D by 2, and in between the plates there is a dielectric of dielectric constant K. So the new capacitance C new will become how much? Area of the plate remains same, epsilon naught, there is a dielectric, so its dielectric constant we have to put K upon thickness between them is now not D, it is D by 2. This I can write as this 2 will go up, so 2K times A epsilon naught by D. Can I write so? Yes. Is equal to twice of K. K is given how much? 6. And A epsilon naught by D is nothing but C, whose value is given to be 8 into 10 to the power minus 12 farad. This you can simplify, that is your answer. Next question, 2.6, you see. 3 capacitors, each of capacitance 9 picofarad, are connected in series. What is the total capacitance? You know students, total capacitance will be given by the formula 1 by C net is equal to 1 by C1 plus 1 by C2 plus 1 by C3. So that becomes 1 by C plus 1 by C plus 1 by C, that is 3 by C, and this implies net capacitance will be how much? C upon 3. C upon 3 means 9 upon 3, that is 3 picofarad. This is bit A. And in part B they ask, what is the potential difference across each capacitor if the combination is connected to 120 volt supply? This combination is connected to 120 volt supply, then what is the potential difference across each capacitor? Let the potential difference across each capacitor be V1, V2, V3. But because the capacitances are identical, they will have same potential difference, that is VV and V. So this V and this V total becomes 3V. 3V is equal to 120. If you choose this point as A, this point as B, this point as C, this point as D, then potential difference between points A and D, VA minus VD, is how much, student? That is 120 volts. Now VA minus VD I can write like this: VA minus VB plus VB minus VC and plus VC minus VD, that is 120 volts. these will segregate them like this. VA minus VB is V, VB minus VC is also V, VC minus VD is also V. So V and V becomes 3V, 3V is 120, so V is 120 by 3, that is 40 volts. So across each capacitor the potential difference will be 40 volts. Our next question is identical, students, that is based on parallel combination. So let's see. So the question is like this: there are three capacitors of capacitances 2 picofarad, 3 picofarad and 4 picofarad. They are connected in parallel. Number A that they ask is this: what is the total capacitance of the combination? Since they are in parallel, total capacitance C net will be simply C1 plus C2 plus C3. That becomes 2 plus 3 5, 5 plus 4 9 picofarad as the answer. Now in bit B what they ask: determine the charge on each capacitor if the combination is connected to a 100 volt supply. So this combination of three capacitors are connected to a 100 volt supply. Then you have to find charge on each of these three capacitors. Let us assume charge on this capacitor be Q1, here it will be Q2 and here it will be Q3. Then here it will be minus Q3, minus Q1, minus Q2. Is it clear, students? So we take this to be plus, this to be minus. So plus Q3 minus Q3 plus Q2 minus Q2 plus Q1 minus Q1. The total charge is Q, that Q is equal to Q1 plus Q2 plus Q3. But you don't have to find Q. You have been asked to find these three charges on the capacitors. So for finding these charges, we will simply use the formula Q is equal to C times V. Now for the first capacitor, that means for capacitor C1, the charge on it Q1 will become its capacitance C1 times potential difference. Now all these three capacitors are connected in parallel. In parallel, you know, the potential difference across each capacitor will be same. That will be how much? 100 volt. So here V, it becomes C1V. C1 is how much? C1 is 2 picofarad, means 2 into 10 to the power minus 12 farad. And V is how much? 100. So this becomes 2 into 10 to the power minus 10 coulomb. Likewise, capacitances C2 and in capacitors C2 and C3, you can find the net charge Q2 and Q3 using the formula C2V and C3V. I think you can do it yourself, students. So let's proceed for next question. Question number 2.8 is the next one. The question is like this: in a parallel plate capacitor with air between the plates, each plate has an area 6 into 10 to the power minus 3 meter square. Distance between the plates is 3 millimeter. So 3 millimeter we can write as 3 times 10 to the power minus 3 meters. Number A that is asked: calculate the capacitance of the capacitor. It's a simple one. The capacitance will calculate using the formula A epsilon naught upon d. Since it is air, for air we take K as almost 1. So you can put the value of A, D and epsilon naught to get the value of this C in farad. Part B, calculations students you have to do yourself. Second part, what they ask, if this capacitor is connected to 100 volt supply, what is the charge on each plate of the capacitor? Charge on the positive plate, Q is given as C times V. C you have already calculated, V will put as how much? 100 volt. So therefore answer will be charge on each plate will be plus Q and minus Q. Suppose this answer you get as X. So plus X coulomb and minus X coulomb, because you know in capacitor one of the plates will be positive and the other plate will be negative. So question 2.8, the answers will be this much. Now why I am putting these answers separately? Because in question number 2.9 you will need them. So let's proceed students for the next question 2.9. This is very important and is a conceptual question, so understand it carefully. 2.9 says explain what would happen if in the capacitor given in exercise 2.8, that means in this particular question, a 3 mm thick, remember students here the thickness D was how much? 3 millimeter. So a 3 mm thick mica sheet is inserted between the plates of the capacitor. This mica sheet has a dielectric constant K that is given in the question as 6. So K is equal to 6. And it has two parts in this question, case 1, case 2. So A and B. We will discuss A first. So I am reading the question again. So what would happen if a thick mica sheet, 3 mm thick mica sheet of dielectric constant 6 were inserted between the plates number A while the voltage supply remain connected. So voltage supply remains connected. That means without disconnecting the battery, a dielectric is inserted. So what would happen? What would happen means you have to find Q, C and V. What would happen to the charge on the capacitor, what would happen to its capacitance and what would happen to its potential difference. Number 1 we'll talk about potential difference. Since the battery remains connected, you should write the language yourself. Since the battery remains connected, the potential difference will remain same. Whatever potential difference appears between the plates of the capacitor, remember students, that is because of the battery. It's the duty of the battery to create a potential difference. So this potential difference is how much? 100 volt. Even if we insert a dielectric, something will go on, but the battery will do its work. It will continue to create a potential difference of how much? 100 volt. So what will be your answer? Since the battery remains connected, the potential difference between the plates of the capacitor would remain same. That means V is equal to how much? 100 volts. Then second part. Second part we will talk about capacitance. Since capacitance, you know, it has nothing to do with Q and V. It does not depend upon Q and V. It depends upon A and D. And if there is a dielectric, this. So earlier it was air, so the formula was this. Now we insert a dielectric sheet, therefore the new capacitance C dash we can write will become how much? A epsilon naught K upon D. This is K times A epsilon naught upon D. What is A epsilon naught by D? That is 18 picofarad. That is C. C was the answer for capacitance in question 2.8. The new capacitance C dash will be K times C. K times C means 6C. You put the value of 6. 6 into 18 picofarad will be your answer. So capacitance will increase by a factor of 6. You should write that language, that capacitance will increase by a factor of 6. And then at last we will talk about charge on the plates of the capacitor. See, charge on the plates of the capacitor, Q dash I am writing, is now new capacitance C dash into new potential difference V dash. But I have discussed potential difference does not change. So V dash will be same as V, but capacitance has changed, so it becomes C dash. So C dash is how much? 6 times 18 picofarad, this one, and V is how much? 100 volt. So C dash I'll write as 6 times C was 18 picofarad, means 10 to the power minus 12, sorry, 6 into 18 times 10 to the power minus 12, this is 6C, and then V is how much? 100, this much coulomb, you can calculate it yourself. And in terms of Q, if you wish, then you can write like this. C dash is how much? 6 times C. 6 times C. What is C into V? That is Q. Q is CV. So it will become 6 times Q. Whatever was your answer in the last question 2.8, 6 times of that will be the present answer. Let's see case B. Case B, it is being asked in the question, what would happen if the mica sheet is inserted between the plates after the supply was disconnected? That means dielectric is inserted after disconnecting the battery. Disconnecting the battery. See, the sequence of steps are different in steps A and B, in questions A and B. Here first of all we will find capacitance. Now see, the battery is disconnected. First battery is disconnected, so the potential difference was how much? Initially it was 100 volt. After disconnecting the battery, now the dielectric is inserted. So the capacitance will change. C dash will become how much? Earlier it was A epsilon naught by D, now it will be A epsilon naught K times D. So the capacitance will increase by a factor of K. K we have discussed, students, it is how much? 6. So this becomes 6 times C. So same thing you can write, capacitance increases by a factor of 6. Next, what would happen to Q and what would happen to V? So please listen very carefully, students. When there was air, the electric field between the plates of the capacitor, while deriving the capacitance of parallel plate capacitor, we had derived it. E was how much? Sigma by epsilon naught. And when this space is filled with a dielectric of dielectric constant K, then the electric field between the plates become how much? This, if I write as E naught, this becomes E naught upon K. You know this. Electric field will be decreased by a factor of K. So it becomes a sigma by epsilon naught into K. If this is E naught, this becomes E naught by K. So remember, students, whenever a dielectric is inserted between the plates, then you know, and there is no battery connected, then the electric field is reduced by a factor of K. You know, students, potential difference between the plates of the capacitor is given by the formula E into D. D is the distance between the plates. In this question, the separation between the plates is not changed, so V will depend upon E. On inserting the dielectric, E decreases by a factor of K. Since E becomes E naught by K, therefore potential difference between the plates of the capacitor, which is E into D, will become how much? E naught by K into D is equal to, this is suppose new potential difference, E naught into D. E naught was the previous in air, the value of electric field. So E naught into D is your potential difference initial, that is V upon K. V was how much? 100 volt and K is how much? 6. 100 by 6 you can calculate that much volt. I am repeating this answer. What I told, if the battery has been disconnected, here what I told, if battery remains connected, it is the duty of the battery to create potential difference. So in this case, in case A, let me tell you, students, please be very particular about this particular question. It's very important. In this question, what I told, voltage supply remains connected, so V will remain same. If V remains same, electric field will also remain same. Capacitance we have discussed, capacitance decreased by a factor of, increased by a factor of k. And charge on the plates of the capacitor Q dash, it also increased by a factor of k. This was in A. In part B, what will happen? Will potential difference remain same? No. Will electric field remain same? No. Why? The new electric field E dash will become original electric field by K. The new potential difference V dash will become original potential difference by K. Capacitance, same situation. C dash will become K times C. And Q dash, we will see what happens to that. So here, since the battery has been disconnected, now it has no role in controlling the potential difference. Potential difference will depend upon electric field. Since electric field decreases by a factor of k, potential difference will also decrease by a factor of k. So it becomes 100 by k, that is 100 by 6 volts. And number 3, charge on the capacitor Q. Suppose the new charge is Q dash. See, somewhere I have used the symbol E naught, but you try to use the same symbol. I have taken E naught and E, and here I have taken E dash and E. E is original, E dash is final. So E is original, E dash is final, and so on. So the new charge on the capacitor is a new capacitance times new potential difference. C dash times V dash. What is new capacitance? New capacitance is 6 times C. And what is new potential difference? The V dash is V upon K. What is K? 6. So 6 will cancel. We get how much? C times V. So C times V, you can get the answer on calculating. So this C times V, C is original capacitance, V is original potential difference. So C times V will give you original charge which we had got in 2.8. So I don't remember that value. Whatever this answer will be same as that in exercise 2.8. Why does this happen? This, instead of doing it this way, you can also think that since the battery has been disconnected in case B, now the charge has no path to flow. Whatever charge had developed on the capacitor, the same charge has to be present. Where will it go? Whether you insert a dielectric or whatever you do. But since there is no path for the charge to flow, therefore the Q will remain same. And that is what we have got using this particular formula also. Students, I strongly recommend you to see this particular solution of 2.9 twice at least, and then do it yourself, understanding each and every step. What would happen to V, what would happen to E, then C, then Q. And there is one more thing which I leave it to you, electrostatic energy. What will happen to the electrostatic energy, whether it will increase by a factor of k, whether it will decrease by a factor of k in both the cases, when the battery remains connected, when the battery gets disconnected. Please try to do it yourself. It's a very, very important question. 2.10 is a simple question, students. It will be based on the formula for energy in a capacitor, that is half CV square or Q square by 2C. So I would recommend you do it yourself. Last question of this exercise in the first part before additional is 2.11. The question reads like this: a 600 picofarad capacitor is charged by connecting it to a 200 volt supply. When you charge it by 200 volt, it will develop some charge plus Q and minus Q, where Q is equal to CV. Next, what is done? It is then disconnected from the battery, from the supply, and then it is connected to another uncharged 600 picofarad capacitor. Identical capacitor was used, uncharged, and these two are connected together as shown. Question that is asked is how much electrostatic energy is lost during this process. Suppose this is C, C is this much and V is this much. So that will give you on charging, charge on the capacitor as C times V. So this becomes 6 into 10 to the power minus 10, 100 and pico, and this becomes 2 into 10 to the power 2, and that much coulomb. So this becomes how much? 6 into 2, 12 into 10 to the power minus 8 coulomb. Knowing the charge on the capacitor, now you can find initially the energy stored between the plates of the capacitor. In this region there will be energy, and that energy you can use any formula. Either you use half CV square or you use q square by 2c. You can calculate that yourself, and that will be in joules. This is our step number 1. We found the charge on the plate and we found the initial energy in this region between the plates of capacitor. Next, what is done? The capacitor is, after it has got charged with this much value of charge, it is connected to another identical capacitor. Now see, these two will be at same potential, these two plates will be at same potential, and the charge on these two will also be identical because charges will distribute within them. Remember students, whenever one conductor is connected to another conductor by a wire, these two conductors will allow the charges to flow only as long as their potentials are not same. That means after some time their potentials will become identical. So these two will come at same potential. For that, this charge will distribute from this charged plate to this uncharged plate, and it will flow till the potential becomes equal. By symmetry, you can say, since these two capacitors are identical, charge will distribute equally. Earlier the charge was q, now this will become q by 2, this will become q by 2. Law of conservation of charge. So charge would distribute equally on two capacitors, and they will be at same potential also. Let this charge on the capacitor be q dash, this will become minus q dash, this will also be q dash, this will be minus q dash, and the potential difference between the plates of the capacitor will be now V by 2, because charge on each plate has become q dash, which is how much? Q by 2. Why q by 2? Whatever charge was there on one plate, that charge now has to distribute between two plates and equally. So if it was q, half of it will be distributed to this becomes q by 2, this becomes q by 2. When charge has reduced to half, we know q is equal to c into v. If charge is reduced to half by a factor of this much, then potential difference will also reduce by a factor of this much, by a factor of 2. If q becomes q by 2, v also becomes v by 2. That is what I have written. This potential you can write v by 2. V by 2 means 200 by 2, that is 100 volt. Now the new potential energy between the plates of the capacitor, final, I am writing. How many capacitors are there? 2. Are they identical? Yes. Are charges same? Yes. Are potential difference same? Yes. So I will multiply energy of one capacitor by 2, because there are two capacitors, to get the total energy, and energy of one capacitor will be how much? Q dash square upon twice of its capacitance C. But what is Q dash? Q dash is Q by 2. So Q dash is Q by 2, so Q by 2 whole square becomes Q square by 4, and this 2C will be there. So this becomes equal to half, I'll take it out, and whatever is left behind, Q square by 2C. Now this Q square by 2C I have already calculated, students. Suppose this answer was x joules. So this will become how much? Half of x joules. Please do the calculations yourself. Question they have asked, how much electrostatic energy is lost? So energy lost during this process, energy lost will be initial energy minus final energy, that is x minus x by 2 joules. So what will be our x minus x by 2 joules? That will become x by 2 joules. I will stop here, students. Please try the additional exercise also, and if you wish, we could discuss some of the additional exercise questions in the next class. Till then, goodbye, take care and read well. Thank you.